Hey guys, so this is my video on series and parallel combinations. Alright, so a series parallel combination is a circuit that has part series and part parallel. So we can't just use our rules for series circuits, we can't just use our rules for parallel circuits because it's a mixture between the two. For example, I have these two in series, these two in series, but this whole branch, and this whole branch is in parallel with each other. So I'm about to go over a few example problems because the best way to do this is to just solve example problems. But I do have some general, very general steps on how you can solve them. So the first step that you want to do when solving series and parallel combinations is to redraw the circuit and find the equivalent resistance. REQ. Now, when you're redrawing a circuit, we want to keep up with the resistors. So there's a naming convention that I like to use. So this convention is whenever you combine resistors, keep track of those resistors using the subscript of the resistors that you combine. So for example, if you combine R1 and R2, the new resistor of those combined ones is going to be called R12. If you combine R2 and R3, it's going to be called R23. Now let's say you combined R1 and 2, and then you combined R2 and 3. So you have R1 and 2, which you combined, and then you combine that with R2 and 3, which you already combined. We're going to call this one R1, 2, comma, 2. Oh, sorry. If this is R1, 2, and you combine that with R3, 4, it's going to be called R1, 2, comma, R3, 4. Now, let's say we combined R1, R2, R3, and R4 in series. So we have R1 and R2 and R3 and R4. This would be R1, 2, 3, 4. Peep the difference. R1, 2, 3, 4 is when we add all these in series. But let's say we added 1 and 2 in series and 3 and 4 in series, but they're both parallel with each other. That will be R1, 2, comma, 3, 4. And I have some examples to show you. So right here, when I'm combining these, this is going to be R1, 2, 3. And it's going to be one resistor. All right, for this example, this is going to be R1, 2 for this branch when I combine them, and this is going to be R3. So when I combine these two and then combine it with this one, it's going to be called R1, 2, comma, 3. Right here, I have 4 resistors in series, so it's going to be R1, 2, 3, 4. Then right here, I have 1 and 2 in series, so I'm going to add those together to get R1, 2. And then I'm going to have these two in series, which will be R3, 4. So if I combine those two branches, I'm going to get R1, 2, comma, 3, 4. All right, so the first thing, redraw your circuit and find the equivalent resistance. You might have to redraw your circuit a few times, and then make sure you keep up with the resistors you combine. And then the second step is to work backwards. And when you're working backwards, you have to think about how you combine resistors. So the big question you always want to ask yourself is, how did I combine these resistors? Let me put a nice big bubble around this. golden question we always want to ask ourselves. How did I combine the resistors? If I combine them in series, remember, series is same current. If I combine them in parallel, same voltage. And then, really quickly, remember, in series, when we add resistors, it's just R1 plus R2 plus R3 plus R4. But in parallel, when we add resistors, we don't do that. We have to do the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So just remember that for parallel, because I don't want you guys to see something that looks like this, and this is 20 and this is 40. The equivalent resistance is not 60. The equivalent resistance is 1 over 1/20th plus 1/40th. All right, so with that being said, let's just jump straight into problems. All right, so I have my circuit, series parts, series parallel combination. All right, so let me start off by adding all my resistors in. So R1 is 20, R2 is 40, R3 is 60, R4 is 80, and then R5 is 100. And then I also know that my total battery voltage, is 30. Now, I'm not going to go ahead and solve this all for I's, all for V's first. I'm going to find some I's, some V's based on the circuit, all right? So first thing I want to do is combine some resistors in series. So I'm going to combine R1 and 2 and R4 and 5. So R12 is 40 plus 20, which is 60. R3 is 60. And R4, 5 is 180. All right, but I want to simplify this until I have one resistor. So now all those are in parallel. So when I combine those, it's going to be R12, comma 3, comma 4, 5. Since I added 1, 2 with 3 with 4, 5. And then this is 30 volts. So that's going to be equal to 1 over, since it's in parallel, 1/60th plus 1/60th plus 1/180th. One 60th plus 1/60th plus 1/180th. And then 1 over that answer gives me 25.71. Let's go ahead and add that in our chart for our equivalent resistance. 25.71. All right. Now that I know my total resistance, I know my total voltage, let's go ahead and find the total current. So total current is going to be equal to total voltage over equivalent resistance. 30 over 25.71. Which gives me 1.17 amps. Well, let's say 1.167 amps. So add that in, 1.167 amps. All right, now, that was the easy part, breaking down the circuit, getting to this. Now what we have to do is work backwards. So starting from here, work up to that picture to figure out all the other things. So question we always want to ask ourselves is, how did I get to this part? What did I combine? So in order to get here, I combine things in series. And what do I know about, in parallel? Here, to go from here to here, are combined in parallel. What do I know about parallel circuits? They have the same voltage, all right? So that means the voltage here, which is 30 volts, is going to be the voltage here, here, and here. Since this gets all the 30 volts, these get 30 volts. 30 volts for that branch, 30 volts for this branch, and 30 volts for this branch. Now, the only time I can ever add anything in this chart if it's for one single resistor, not if it's being shared, okay? So it has to be for one resistor. So this is 30 volts for this branch, but that's broken up between 1 and 2. So 1 and 2, V1, V2 have to add up to give me 30. So it's split. Can't do anything with 1 and 2. 4 and 5 have to add up to 30 volts. So I can't do anything with 4 and 5. But if I look at R3, it's getting all the 30 volts. So that means V3 is 30 because it's not being split up. So let's add 30 volts for V3. All right. Can't do anything with 1, 2. Can't do anything with 4, 5 in our chart yet. So what we have to do is work backwards again. So how did we combine 1 and 2 to get here? Well, if I look at this picture looks like they were in series. So to get from here to here, I did series. So series has the same current. So if I can find the current at this point, I know the current at this point and this point. And the same thing with 4 and 5. I combine these in series. So if I know the current at this point, I know it at this and this point. And I can calculate that current because I know the voltage right here and I know this resistance right there. So for 1 and 2, I12 is equal to V12 over R12. So V12 is 30 volts, and then R12 is 60. So that gives me 0.5 amps. So let me do 0.5 amps for 1, 0.5 amps for 2, because they're in series, same current as here. Now let's do 3 and 4. 4 and 5. I45 is equal to V45 over R45, which is 30 divided by 180, which gives me 0.167 amps. So for 4 and 5, it's 0.167 amps, 0.167 amps. Now, what's super nice about this is now that I have 2 of the 3 things, I can solve for the missing one. So, for instance, we know Ohm's law is V is equal to IR. If I know I, if I know R, I can find V. If I know V and if I know R, I can find I. If I know V and I know I can find R. So, since I know 2 things from each row, I can solve for the missing one. So, if R1 is 20, I1 is 5. If I want V, V1 is equal to I1 times R1, 0.5 times 20 gives me 10 volts. .5 times 40 gives me 20 volts. 30 divided by 60 gives me 0.5 amps. Now, before I continue, really quickly, remember I told you that V1 and V2 have to add up to give you 30? 10 plus 20 gives us 30. And remember I said 4 and 5 have to add up to give you 30? So let's see what those voltages are. 0.167 times 80, 13.36. And then 0.167 times 100, 16.7. So, if I add these together, I'm going to get about 30. If it's not exactly 30, it's because I rounded a little bit, but it'll be pretty close. Now, to find the total power, I do IV. I know all my I's, I know all my V's now. So, if I do 30 times 1.167, I get the total power to be 35.01 volts. I mean watts. If I do 10 times 0.5, I get 5 watts. 20 times 0.5 gives me 10 watts. 30 times 0.5 gives me 15 watts. $13.36 times 0.167 gives me 2.23 watts. And then 16.7 times 0.167 gives me 2.79 watts. All right, so we just did our first series parallel combination. All right, time to move on to the second problem. Let me add everything. First, I'm gonna make the correction in my chart because I forgot to I made some typos, sorry. All right, let's first add everything we know. Total voltage is 30 volts. And then we have 20, 40, 60, 80, 100 again. First thing we want to do, find REQ by simplifying. First thing I want to do is add R1, R2, and R3 because they're in series. We know they're in series because if we look, they're on the same exact wire. What goes through R1 will go through R2, will go through R3. And then 4 and 5 are in series because whatever goes through R4 will go through R5. This will be R4, 5, which is 180. And this is R1, 2, 3, which is 60 plus 40 plus 20, which is 120. All right, and 30 volts. Let's simplify this again to get one resistor. This will be R1, 2, 3, comma 4, 5, which will be 1 over 1 1/80th plus 1 1/20th because they're in parallel. So let's see, 1 1/80th plus 1 1/20th. 1 divided by that answer will give me 72 ohms. So that's my equivalent resistance. Let's add that in the chart. All right, know my total voltage, know my total resistance. Let's find total current. $30 divided by 72. .417 amps. 0.417 amps. Now, let's start to work backwards. If this is 30 volts, this gets all of it. So how did I combine this? I combined this, looking up here, in parallel. So the voltage here is going to be equal to those voltages. If this is 30 volts, then that's 30 and that's 30. So 30 volts, 30 volts. Now, the next, so if I look, 4, 5 have to add up to give me 30, and 1, 2, 3 have to add up to give me 30. But I can't add anything in my chart because I don't know how it's split up. I don't have anything for just one resistor. This is 4, 5 combined. This is 1, 2, 3 combined. I don't have 4, 5. I don't have 1, 2, 3. I have 1, 2, 3, 4, 5. So I need to know the individuals. All I know is that the voltages add up for this. So the next question I have to ask myself is, how did I combine 4 and 5? Looking up here, 4 and 5, since they're on the same wire, I combined them in series. So series has the same current. So let me solve for the current here to get these currents. So I45 is equal to V45 over R45. V45 is 30 volts combined. So 30 divided by the combined resistance, which is 180. 0.167 amps. And then I combined 1, 2, and 3. Oh, sorry. If that's 0.167 amps, that means this is 0.167 and this is 0.167. Let me add that in my chart now. And then 1, 2, 3 was combined in series, so I123 is equal to V123, which over R123, which would just be that 30 divided by 120, which is just a quarter, which is 0.25 amps. 0.25 amps, 0.25 amps, 0.25 amps. Cool. And then we can find our V's by doing the I's times the R's. So 0.25 times 20, 0.25 times 40, 0.25 times 60, 0.167 times 80, 0.167 times 100. That'll give us all that. Once I have all my V's, I can find my P's by doing all these I's times the V's. All right, moving on to number 3. This circuit. First thing first, let me just add everything in my chart. All right. 20, 40, 60, 80, 100. Total voltage is 30. Boom. All right. So, find REQ. So, first thing I want to do is, this is in series, this is in series. So, I'm going to add the series parts. Now, R1 is not in series with 2 and 3. And it's not in series with 2 and 3 because if current's going this way, whatever goes through R1 is getting split. So whatever goes through R1 is not going through R2 or R3. It's getting split right here. So this is not in series with anything else. All right? So let's just keep R1 right there. Now we're going to combine 2 and 3. And we're going to combine 4 and 5. So R2, 3, 60 plus 40 is 100. Then R4, 5, 100 plus 80 is 180. And then this is 30 volts. I'm not done simplifying because I need one resistor. Next, if I look, R2, 3 and R4, 5 are in parallel. So let me simplify that parallel part. So I still have my R1. It's just hanging tight right there. So I have R1, which is 20. Then I have R2, 3, comma, 4, 5. Which, since I combined them in parallel, it's 1 over 1 100th plus 1 180th. $64.29. All right. And then still 30 volts. I'm not done yet because I have to simplify it one more time to get one resistor. So since these are in series, because they're on the same wire now, I'm going to do 64.29 plus 20, which gives me 84.29. And that's going to be R1, comma 2, 3, comma 4, 5. All right, so my equivalent resistance is 84.29. I know my total voltage, know my total resistance. Let me find my total current. $30 divided by 84.29. 0.356 amps. Let me add that in. Time to work backwards now. So I have 1, 2, 3, 4, 5. How did I combine this? Oop, I combined them in series. So if these are in series, they have the same current. So if I know the current right here, that will give me the current right here and the current right here. So the current right here is going to be 30 divided by 84.29, which I did, 0.356 amps. 0.356 amps. That means this is 0.356 amps. This is 0.356 amps. All right, next thing I ask myself is, can I add anything in my chart? And I can, because for R1, it's getting all 0.356 amps. You see that? For 2, 3, 4, 5, I don't know, that the currents add up to give me this, but that 0.356 amps is split somehow between 2, 3, 4, and 5. And I don't know yet, so don't worry about this. But R1 is all by itself, so 0.356 amps is R1. Next thing I do is I look. How did I combine R2, 3, 4, 5? I combined those in parallel. So I know parallel has the same voltage. So if I know the voltage here, I'll know the voltages right here and right here. But be careful, because the voltage right here is not 30. Because remember, this is a series circuit. They add up to give you 30. So I don't know if it's 10, 20. I don't know if it's 25, 5. I don't know if it's 15, 15. So I have to calculate the voltage right here. So V23, 45 is equal to I23, 45 times R23, 45. The nice thing is, boom, I know the current of R2345, 0.356. And the resistance is 64.29, which I calculated earlier. Let me calculate what that is. That gives me 22.9 volts. So that means this is 22.9 volts. That means for R23, that's 22.9, because they're in parallel, same voltage. And for R45, 22.9 volts. Cool. Now I'm right here. I still can't add anything in my chart, though, because this isn't V2, this isn't V3. It's not V4, it's not V5. This is V23, this is V45. They have to add up to give me 22.9, but I don't know how it's broken down. But if I look at how I combined R23, I combined it in series. So if I can find the current right here, I can find the currents at these 2 points. If I can find the current at 4, 5, I can find the current at 4 and 5, because those are also in series. So let me find 2, 3, the current there. So the I23 is going to be V23 over R23. The voltage is 22.9 for that branch, divided by the resistance, which is 100. That's going to give me 0.229 amps. So R2 is 0.229 and R3 is 0.229. That means I can add that on my chart. I2, 0.229 amps. I3 is 0.229 amps. I can do the same exact thing with 4 and 5. If I know the current here, I can find those two. So I45 is equal to V45 over R45, which is 22.9 divided by 180, which gives me 0.127. That means the current for 4 is 0.127. That means the current for 5 is 0.127. Cool. And y'all know how to find the rest. V is IR, P is equal to IV. Last but not least, almost done. Circuit number 4. Let's start with finding the equivalent resistance. Also, let me fix my chart. All right. 20, 40, 60, 80, 100. First, equivalent resistance. If these are in series, add those up. Parallel, parallel. But if these are in series, let me just add those, and that's going to give me R123, which is 60 plus 40 plus 20, which is 120. And then these are in parallel, so I can add those up. R45, which is 1 over 1/80th plus 1 100th. 1 over 80 plus 1 over 100. Then 1 over that answer gives me 44.4. This is 30 volts. Simplify this again. They're in series, so I just add those up. So this is going to be R123, 45, which is 120 plus 44.4, which will be 164.4 ohms. All right. So my equivalent resistance is 164.4. All right. Now, let me find my total current, because I know my total voltage is 30. I total is equal to V total over RAQ. 30 divided by 164.4 gives me 0.182 amps. Now, ask myself, how did I combine these resistors? I combined them in series. So if I combine them in series, if this is 0.182 amps, that means this is 0.182 amps, this is 0.182 amps. Now, I can't add anything in my chart because this is 1, 2, 3, this is R45, nothing by itself. So working backwards, how do I combine 1, 2, and 3? I combined 1, 2, and 3 in series, all right? Which is nice. So that means the current here is equal to the current here, here, and here. So if this is 0.182, 0.182, 0.182, 0.182. So let me just go ahead and show that on my diagram. And I can add that to my chart because I know I know I1, I know I2, I know I3. 0.182 amps, 0.182 amps, 0.182 amps. Now, how did I combine 4 and 5? I combined 4 and 5 in parallel. So if I combine those in parallel, they have the same voltage. Now, I don't know the voltage right here. I know these two have to add up to give me 30, but I don't know what this is. Is this 1020? Is it 1515? Is it 25.5? So let me find the voltage right here. V45 is equal to I45 over R45. I know the current for 45 is 0.182. I know the resistance for 45 is 44.4. 0.182 times 44.4 gives me 8.08. So if this is 8.08 volts, this is 8.08 volts, and this is 8.08 volts. Let me add that in. 8.08, 8.08. And then the rest of this is solving for your V's, I times R. And this is going to be I is equal to V over R. And I guarantee you that the voltages for 1, 2, and 3 are going to be, once I add all, so if I found the voltage right here, it's going to most likely be 30 minus 8.08, 21.92. So I know that V1 plus V2 plus V3 is going to have to add up to give me 21.92. All right, so hope this was helpful. Please let me know if you have any questions. Your quiz will be sometime next week. All right, thank you.